Open up Resources, Illustrative Mathematics, 7th grade, Unit 3, Lesson 1. For problem number 1, the question is, how long are the side lengths of a square that has a diagonal of 9 centimeters? One thing you should know is the perimeter of a square is approximately 2.8 times its diagonal. So for this square, we can multiply 2.8 times 9 centimeters. That equals 25.2 centimeters. The four side lengths would be equal to the perimeter divided by 4. 25.2 centimeters divided by 4 sides equals 6.3 centimeters. All the side lengths of this square would be approximately 6.3 centimeters in length. Problem number 2. The area of a square grows at a faster rate than the length of the diagonal. So the area and the diagonal are not proportional. The perimeter of a square grows at the same rate as the square's diagonal. So the square's perimeter and its diagonal are proportional. The side lengths of a square grow at the same rate as the square's diagonal. So the square's side lengths and its diagonal are proportional. Number 3. Though this point seems to be a little bit above the line runs through the origin, which means it could be proportional. The measurements may not be perfect. Number 4. 25 minutes equals approximately 380 gallons of water. 500 gallons of water equals approximately 35 minutes. The rise is 150 gallons of water, and the running time is 10 minutes. That means that for this graph, the rise over run is 150 over 10, which is equivalent to 15 over 1. That equals 15 gallons of water per minute.
7th grade, Unit 3, Lesson 2, Exploring Circles. Glossary terms. Circle. A circle is made out of all the points that are the same distance from a given point. For example, every point on this circle is 5 centimeters away from point A, which is the center of the circle. Circumference. The circumference of a circle is the distance around the circle. If you imagine the circle as a piece of string, it is the length of the string. If the circle has a radius, r, then the circumference is 2 times pi times r. The circumference of a circle of radius 3 is 2 times pi times 3 equals 6 times pi, which is about 18 85/100. Diameter. A diameter is a line segment that goes from one edge of a circle to the other and passes through the center. A diameter can go in any direction. Every diameter of the circle is the same length. We also use the word diameter to mean the length of this segment. For example, D is the diameter of this circle with center 0. All these diameters are the same length for this circle. Radius. A radius is a line segment that goes from the center to the edge of a circle. A radius can go in any direction. Every radius of the circle is the same length. We also use the word radius to mean the length of this segment. For example, r is the radius of this circle with center 0. Each of these line segments represent the radius for this circle, and each of these line segments are all the same length. Learning goals. Compare orally different ways to measure a circle and generalize the relationship between radius and diameter. Comprehend the terms diameter, center, radius, and circumference in reference to parts of a circle. Describe orally and in writing the defining characteristics of a circle. Student learning goals. Let's explore circles. Student learning targets. I can describe the characteristics that make a shape a circle. I can identify the diameter, center, radius, and circumference of a circle. Problem number 1. Use a geometric tool to draw a circle. Draw and measure a radius and a diameter of the circle. One geometric tool that you could use is called a compass, and you can use this compass to draw a circle. Imagine that this was a perfect circle. This would be the diameter, and let's say it measures 2 inches. Since the diameter measures 2 inches, that would mean that the radius would measure 1 inch. Problem number 2. Here is a circle with center H and some line segments and curves joining points of the circle. Identify examples of the following. Explain your reasoning. A. Diameter. Line segments DG and AE are line segments that represent the diameter. They are line segments that go through the center from one side of the circle to the other. Radius. Line segments AH, DH, EH, and GH are all line segments that represent the radius of this circle. They are line segments that go from the center to the circle. Problem number 3. Lynn measured the diameter of a circle in 2 different directions. Measuring vertically, she got 3.5 centimeters, and measuring horizontally, she got 3.6 centimeters. Explain some possible reasons why these measurements differ. Maybe Lynn did not measure from the tallest section of the circle, or maybe it was not a perfect circle. Problem number 4, from 7th grade, Unit 2, Lesson 1. A small test batch of lemonade used 1/4 cup of sugar added to 1 cup of water and 1/4 cup of lemon juice. After confirming it tasted good, a larger batch is going to be made with the same ratio using 10 cups of water. How much sugar should be added so that the large batch tastes the same as the test batch? I'm going to make a double number line representing cups of sugar and cups of water. I'll put tick marks representing 0 through 10. For 1 cup of water, there's 1/4 cup of sugar. Moving from left to right on the bottom number line that represents cups of water, I can count by ones, all the way through 10 cups. And the top number line represents sugar, so we will be counting by 1/4 cups of sugar. For 10 cups of water, we'd have 10/4 cups of sugar, and 10/4 cups of sugar is equivalent to 2.5 cups of sugar. So for the larger batch, we would need 2.5 cups of sugar. Problem number 5, from 7th grade, Unit 2, Lesson 13. The graph of a proportional relationship contains the point with coordinates 3 and 12. What is the constant of proportionality of the relationship? I'm going to make a table with the x value on the left, which is 3, and the y value on the right, which is 12. Since 3 times 4 is 12, the constant of proportionality is 4. Let me give you an example. In the x column, let's put 1, 2, and 3. Multiply 1 times 4 to get 4, 2 times 4 to get 8, and 3 times 4 to get 12. The constant of proportionality is 4.
For 7th grade, Unit 3, Lesson 3, you'll need to follow along with your practice problems and pause or rewind the video when you need more time. There will be no narration, so you'll have to watch closely. for Unit 3, Lesson 4. There is no narration, so you'll have to listen closely while following along with your practice problems. Be sure to pause or rewind if you need more time.
7th grade Open Up Resources Illustrative Mathematics, Unit 3, Lesson 5, Circumference and Wheels. Problem number 1. The diameter of a bike wheel is 27 inches. If the wheel makes 15 complete rotations, how far does the bike travel? 15 rotations times pi times 27 inches. 15 times 27 is 405. 405 times pi is 1,272 inches. The bike would have traveled 1,272 inches, which is equal to 106 feet. Problem number 2. The wheels on Kieran's bike are 64 inches in circumference. How many times do the wheels rotate if Kieran rides 300 yards? Since there are 36 inches in a yard, we need to multiply 300 yards times 36 inches. That gives us 10,800 inches. Since the circumference of Kieran's wheel is 64 inches, we need to see how many times 64 inches goes into 10,800 inches. 10,800 divided by 64 equals 168.75. So Kieran's wheel has to rotate almost 169 times to travel 300 yards. Problem number 3 from 7th grade, Unit 3, Lesson 4. The numbers are measurements of radius, diameter, and circumference of circles A and B. Circle A is smaller than circle B. Which number belongs to which quantity? Let's look at some circles. Circle A is smaller. Now let's look at the numbers. We have a 2.5 and a 5. The 5 could be the diameter of the smaller circle, and 2.5 could be the radius of the smaller circle, since the radius is half the diameter. To find the circumference, we need to multiply 2 times pi times the radius, and 2 times pi times 2.5 equals 15.7, so 15.7 could be the circumference for circle A. Let's look at the other numbers. 7.6 could be the radius of circle B, and 7.6 times 2 would be 15.2. So the diameter of circle B would be 15.2. That leaves us with 47.7. So the circumference would be 2 times pi times the radius. And in this case, 2 times pi times 7.6 equals 47.7. Problem number 4 from 7th grade, Unit 3, Lesson 3. Circle A has circumference 2 2/3 meters. Circle B has a diameter that is 1.5 times as long as circle A's diameter. What is the circumference of circle B? Since the diameter of circle B is 1.5 times larger than circle A's diameter, its circumference is also going to be 1.5 times larger than circle A's circumference. So we can multiply 1.5 times 2 2/3. That's the same as 3/2 times 8/3. That gives us 24/6, and 24 divided by 6 is 4. So the circumference of circle B is 4 meters. Problem number 5 from 7th grade, Unit 3, Lesson 2. The length of segment AE is 5 centimeters. A. What is the length of segment CD? If AE is 5 centimeters, then AC is also 5 centimeters, and AD is also 5 centimeters. So the distance from C to D would be 5 centimeters plus 5 centimeters, or 10 centimeters. B. What is the length of segment AB? Again, if AE is 5 centimeters, then AB will also be 5 centimeters. C. Name a segment that has the same length as segment AB. That's the radius of this circle, so you could pick any segment that looks like the radius. For example, AG, AE. You could even pick AD, AF, or AC.
7th grade, Illustrative Math, Unit 3, Lesson 6, Estimating Areas. Number 1. Find the area of the polygon.
They've provided us with some lengths, and we can use those lengths to help us figure out the missing lengths. For example, 2 centimeters plus 2 centimeters equals 4 centimeters. Now that we found all the missing lengths, we can divide this into rectangles. 3 by 4 equals 12 centimeters squared, or 12 square centimeters. 1 by 2 equals 2 centimeters squared, or 2 square centimeters. And 2 by 3 equals 6 centimeters squared, or 6 squared centimeters. "12 plus 2 plus 6 equals 20. So the area of the entire polygon is 20 square centimeters. Number 2. A. Draw polygons on the map that could be used to approximate the area of Virginia. And B. Which measurements would you need to know in order to calculate an approximation of the area of Virginia? Label the sides of the polygons whose measurements you would need. Note, you aren't being asked to calculate anything. Let's draw the polygons on the map for 2A. To answer 2B, we would need the base and the height for each of these polygons. Number 3. Jada's bike wheels have a diameter of 20 inches. How far does she travel if the wheels rotate 37 times? The diameter is 20 inches. How far would this wheel travel if it rotated 37 times? 37 times 20 times pi. That's about 2,325 inches. Number 4. The radius of the Earth is approximately 6,400 kilometers. The equator is the circle around the Earth, dividing it into the northern and southern hemispheres. The center of the Earth is also the center of the equator. What is the length of the equator? Here's the Earth with the equator, the northern and southern hemispheres, with the tilt. Cut the Earth in half, and you can find the center of the Earth. The radius of the center of the Earth is approximately 6,400 kilometers. The diameter, or the equator, would be 6,400 kilometers times 2 times pi. That makes the length of the equator a little more than 40,000 kilometers. Number 5. Here are several recipes for sparkling lemonade. For each recipe, describe how many tablespoons of lemonade mix it takes per cup of sparkling water. This means that we're going to have to multiply or divide the cups of sparkling water to equal just 1 cup of sparkling water. And whatever we do to one side, we have to do to the other. This diagram illustrates 12 cups of sparkling water, and this diagram represents 4 tablespoons of lemonade mix. 12 cups divided by 12 equals 1 cup. So now we found 1 cup of sparkling water. Well, we'll also have to divide the tablespoons of lemonade mix by 12. 4 divided by 12 is 4 twelfths, and 4 twelfths is equivalent to 1/3. So the ratio would be 1/3 of lemonade mix to 1 cup of sparkling water. This diagram represents 6 cups of sparkling water, and this diagram represents 4 tablespoons of lemonade mix. 6 divided by 6 equals 1 cup of water, and 4 divided by 6 equals 4/6 or 2/3 tablespoons of lemonade mix. The ratio would be 2/3 tablespoons of lemonade mix to 1 cup of water. A ratio of 3 to 5. 5 divided by 5
equals 1, so we have 1 cup of sparkling water, and 3 divided by 5 equals 3/5, so we have 3/5 of a tablespoon of lemonade mix. So the ratio would be 3/5 to 1, or 3/5 of a tablespoon of lemonade mix to 1 cup of sparkling water. A ratio of 1/2 to 3/4. 3/4 divided by 3/4 equals 1, or 1 cup of sparkling water. 1/2 divided by 3/4 equals 1/2 times 4/3, which equals 4/6. 4/6 is also 2/3. The ratio would be 2/3 of a tablespoon of lemonade mix to 1 cup of sparkling water.
Open Up Resources Illustrative Mathematics, Unit 3, Lesson 7, Exploring the Area of a Circle. Problem number 1. The x-axis of each graph has the diameter of a circle in meters. Label the y-axis on each graph with the appropriate measurement of a circle, radius in meters, circumference in meters, or area in meters squared. The first graph shows the relationship between the diameter and area of a circle. It's not a proportional relationship. The second graph shows the relationship between the diameter and the radius. It is a proportional relationship, and the constant of proportionality is 1/2. The third graph shows the relationship between the diameter and the circumference. It is a proportional relationship, and the constant of proportionality is pi. Problem number 2. A. Here is a picture of 2 squares and a circle. Use the picture to explain why the area of this circle is more than 2 square units, but less than 4 square units. The area of the bigger outside square is 2 units by 2 units, which is 4 units squared. So we know the area of the circle has to be less than 4 units squared. Now let's look at the area of the smaller square inside the circle. This smaller square is made up of 4 small triangles. Each of those 4 small triangles are 1/2 of a square unit. So 4 halves actually equals 2. So this smaller square has an area of 2 square units. That means that the area of the circle is larger than 2 square units, but smaller than 4 square units. B. Here is another picture of 2 squares and a circle. Use the picture to explain why the area of this circle is more than 18 square units and less than 36 square units. Let's start with the larger square. 6 units by 6 units. 6 times 6 is 36, so the area of the larger square is 36 square units. Since the circle is smaller than the larger square, the circle is going to have an area that's less than 36 square units. Just like in diagram A, the area of the smaller square inside the circle is half the area of the larger square outside the circle. The area of the smaller square inside the circle is 18 square units. Since the circle's larger than the smaller square that's inside the circle, the area of the circle must be greater than 18 square units. Problem number 3. Circle A has area 500 inches squared. The diameter of circle B is 3 times the diameter of circle A. Estimate the area of circle B. The area of circle A equals the radius squared times pi. So we know that the radius squared times pi equals 500 inches squared because they told us that circle A has an area of 500 inches squared. If circle B's diameter is 3 times greater than circle A's diameter, then that means circle B's radius is also 3 times greater than circle A's radius. That means that the area of circle B is going to be 3 to the second power times greater than the area of circle A. 3 to the power of 2 equals 9. So the area is going to be 9 times greater than 500 inches squared. 9 times 500 inches squared is 4,500 inches squared. So the area of circle B will be about 4,500 inches squared. Problem number 4 from 7th grade, Unit 3, Lesson 5. Lynn's bike travels 100 meters when her wheels rotate 55 times. What is the circumference of her wheels? 100 meters divided by 55 rotations equals approximately 1.82 meters. So the circumference of her wheels is approximately 1.82 meters. Problem number 5 from 7th grade, Unit 3, Lesson 3. Find the circumference of this circle. The diameter is 15 centimeters, and 15 centimeters times pi will give us the circumference. 15 centimeters times pi is approximately 47 centimeters. The circumference of this circle is about 47 centimeters. Problem number 6 from 7th grade, Unit 3, Lesson 3. Priya drew a circle whose circumference is 25 centimeters. Claire drew a circle whose diameter is 3 times the diameter of Priya's circle. What is the circumference of Claire's circle? We know that Priya's circle has a circumference that's equal to the diameter times pi. They told us that the circumference is 25 centimeters, so we can rewrite this as 25 centimeters equals the diameter times pi. Let's figure out what the diameter is. We can divide both sides by pi. On the right-hand side, we have d times pi divided by pi. That equals d. And 25 divided by pi equals 7.96. The diameter is 7.96 centimeters, and the diameter of Claire's circle is 3 times that. So we need to multiply 3 times 7.96. That's 23.88. Now we need to find the circumference of Claire's circle. The circumference will be the diameter times pi. 23.88 times pi. That equals approximately 75 centimeters. Open up Resources, Illustrative Mathematics, 7th grade, Unit 3, Lesson 8, Relating Area to Circumference. Problem number 1. The picture shows a circle divided into 8 equal wedges, which are rearranged. The radius of the circle is r, and the circumference is 2 times pi times r. How does the picture help to explain why the area of the circle is pi r squared? This shape has the same area as the circle. This is more like a rectangle. And it looks even more like a rhombus. You can find the area of a rhombus the same way you find the area of a rectangle, base times height. The average height of this rhombus is the radius of the circle, or half the diameter. The length of this rhombus is half the circumference of the circle. The full circumference would be going all the way around the circle, but as you can see here, that the length of this rhombus just goes halfway around the circumference of this circle. And that length could be represented as pi times r. To find the area of this rhombus, you'd multiply the base times the height. The base would be pi times r, and the height is r. So the area would be pi times r, which is the same thing as pi times r squared. This rhombus and the circle have the same area, pi times r squared. Problem number 2. A circle's circumference is approximately 76 centimeters. Estimate the radius, diameter, and area of the circle. They gave us the circumference, and we know that the circumference is diameter times pi. We also know that the area equals the radius squared times pi. Let's figure out the diameter first. The circumference divided by pi gives us the diameter. The diameter of this circle is 24.2 centimeters. Now let's figure out the radius. The radius is half the diameter. Half of 24.20 centimeters is 12.1 centimeters. Now we have enough information to find the area of this circle. The area is radius squared times pi, or 12.1 squared times pi. The area of this circle is 146.41 times pi, and that is 459.73 centimeters squared. Problem number 3. Jada paints a circular table that has a diameter of 37 inches. What is the area of the table? If the diameter is 37 inches, then the radius is half of 37 inches, and half of 37 inches is 18.5 inches. The area is equal to the radius squared times pi. Since the radius is 18.5 inches, then the area is going to be 18.5 inches squared times pi. The area is equal to 342.25 inches times pi. The area of the table that Jada painted is approximately 1,074.665 inches squared. Problem number 4 from 7th grade, Unit 3, Lesson 4. The carousel on the National Mall has 4 rings of horses. Kieran is riding on the inner ring, which has a radius of 9 feet. Mai is riding on the outer ring, which is 8 feet farther out from the center than the inner ring is. A. In one rotation of the carousel, how much farther does Mai travel than Kieran? Here's a look at the carousel from above, with Kieran's blue inner circle and Mai's orange outer circle. Kieran's radius is 9 feet. That makes her diameter 18 feet. Mai's radius is 8 feet longer than Kieran's radius, so Mai's radius is 17 feet. That makes Mai's diameter 34 feet. The circumference of Kieran's circle is 56.52 feet, and the circumference of Mai's circle is 106.76 feet. That's a difference of 50.24 feet. That means that with one rotation of the carousel, Mai travels 50.24 feet further than Kieran. B. One rotation of the carousel takes 12 seconds. How much faster does Mai travel than Kieran? That would be a distance of 50.24 feet divided by 12 seconds. That's approximately 4.1 feet per second faster. Problem number 5 from 7th grade, Unit 3, Lesson 5. Here are the diameters of 4 coins. A. A coin rolls a distance of 33 centimeters in 5 rotations. Which coin is it? That means it rolled its circumference 5 times and traveled 33 centimeters. The circumference is diameter times pi. 33 centimeters equals diameter times pi. Divide both sides by pi, and you have the diameter equals 10.5. Divide that by 5 for the 5 rotations, and you have a coin with a diameter of 2.1 centimeters, which would be a nickel. B. A quarter makes 8 rotations. How far did it roll? A quarter has a diameter of 2.4 centimeters. 2.4 times pi times 8 rotations. It rolled 60.288 centimeters. C. A dime rolls 41.8 centimeters. How many rotations did it make? The distance the dime rolled divided by pi times the diameter of the dime. The dime made approximately 7.4 rotations. 7th grade, open up resources, Illustrative Mathematics. Unit 3, Lesson 9, Applying Area of Circles. Problem number 1. A circle with a 12-inch diameter is folded in half and then folded in half again. What is the area of the resulting shape? The area of a circle equals the radius squared times pi. Since the diameter of this circle is 12, the radius would be 6. So the area of this circle would be 6 squared times pi, which is approximately 113.04 inches squared. They said that this circle was folded in half and then folded in half again. That's equivalent to 1/4 of the original area. 1/4 of 113.04 equals approximately 28.26 inches squared. The area of the resulting shape would be approximately 28.26 inches squared. Problem number 2. Find the area of the shaded region. Express your answer in terms of pi. First, I'll find the area of the blue rectangle. Then I'll find the area of the 3 circular shapes inside and subtract the area of those circular shapes from the area of the rectangle. To find the area of the rectangle, I'm going to multiply the length times the width. The total length is 30 inches and the width is 18 inches. 30 times 18 equals 540. So the area of this rectangle would be 540 inches squared. We still need to subtract the area of the 3 circular shapes. Along the right side of the rectangle, you can see the diameter for each of the circles. Since the radius is half the diameter, the radius of the bottom circle would be 6 inches. 6 inches squared times pi equals 36 times pi, or 36 inches times pi. Here you can see I've done the same thing to the remaining circles. In terms of pi, the area of the smallest circle is 9 times pi, the medium circle is 20.25 times pi, and the area for the larger circle is 36 times pi. Add them up and their total area is approximately 65.25 times pi, inches squared, since we're talking about area. This represents the total area of all 3 circles, and we need to subtract this from the area of the blue rectangle. In terms of pi, the area of the shaded region is 540 minus 65.25 pi inches squared. Problem number 3 from 7th grade, Unit 3, Lesson 8. The face of a clock has a circumference of 63 inches. What is the area of the face of the clock? Remember, the diameter times pi equals the circumference. To find the area of a circle, we need to know its radius. First, let's figure out the diameter, and then we can cut the diameter in half, and we'll know the radius. We know that the circumference is 63 inches, so the diameter times pi equals 63 inches. Let's divide both sides by pi to get the diameter by itself. The diameter equals 63 inches divided by pi, or approximately 20.06 inches. That means that the radius of the face of the clock is half of 20.06 inches, or 10.03 inches. To help us find the area of the face of the clock, we can substitute the r with 10.03 inches. The area is 10.03 squared times pi. The area of the face of the clock is approximately 315.89 inches squared. Problem number 4 from 7th grade, Unit 3, Lesson 7. Which of these pairs of quantities are proportional to each other? For the quantities that are proportional, what is the constant of proportionality? A. Radius and diameter of a circle. Yes, they're proportional. The radius is always half the diameter. The constant of proportionality is 2 or 1/2. B. Radius and circumference of a circle. Yes, the circumference is 2 times pi times the radius. The constant of proportionality is 2 times pi or 1 over 2 times pi. C. Radius and area of a circle. No, the radius and the area are not proportional. When graphed, it would not form a straight line. Therefore, there is no constant of proportionality. D. Diameter and circumference of a circle. Yes, they're proportional. The circumference is pi times the diameter, so the constant of proportionality is either pi or 1 over pi. Problem number 5 from 7th grade, Unit 3, Lesson 6. Find the area of this shape in 2 different ways. First, let's make it into a rectangle because the area of a rectangle is length times width. 3 meters times 4 meters equals 12 meters squared. So the rectangle has an area of 12 meters squared. Don't forget, we need to subtract the area of the little triangle. And the area of a triangle is 1/2 of the base times the height. This triangle has a base of 2 meters and a height of 2 meters. So half of 2 times 2. Since 2 times 2 is 4, half of that is 2. This triangle has an area of 2 meters squared. Now we need to subtract the area of the triangle from the area of the rectangle. 12 meters squared minus 2 meters squared equals 10 meters squared. The area of this shape is 10 meters squared. Now let's use a different strategy to find the area of this shape. This time I've divided the larger shape up into 3 different shapes: a larger rectangle on the bottom, a triangle on the top left, and a smaller rectangle on the top right. The area of the larger triangle is 3 meters times 2 meters, or 6 meters squared. The area of the smaller rectangle is 2 meters by 1 meter, or 2 meters squared. The area of the triangle is half the base times the height. The base is 2, the height is 2. Half of 2 times 2 is 2 meters squared. Now we need to add the area of all 3 shapes. 6 meters squared plus 2 meters squared plus 2 meters squared. The area of this shape is 10 meters squared. Problem number 6 from 7th grade, Unit 2, Lesson 5. Elena and Jada both read at a constant rate, but Elena reads more slowly. For every 4 pages that Elena can read, Jada can read 5. A. Complete the table. 5 pages that Jada can read divided by 4 pages that Elena reads shows that Jada reads 1.25 pages for every 1 page that Elena reads. We can multiply the number of pages that Elena reads by 1.25 to see how many pages Jada reads. And we can divide the number of pages Jada reads by 1.25 to see how many pages Elena reads. Elena reads 4/5 the amount of pages that Jada reads. So when Jada reads J pages, Elena reads 4/5 of J pages, or 8/10 of the amount of pages Jada read. When Elena reads 1 page, Jada reads 1.25 pages. When Elena reads 9 pages, Jada reads 11.25 pages. When Elena reads S number of pages, Jada reads 1.25 times S number of pages. And when Jada reads 15 pages, Elena reads 12 pages. When Jada reads J number of pages, Elena reads 4/5 or 8/10 of J number of pages. B. Here is an equation for the table. J equals 1.25 E. What does the 1.25 mean? It means that Jada reads 1.25 pages for every 1 page that Elena reads. C. Write an equation for this relationship that starts E equals. That equation would be E equals 4/5 J or E equals 0.8 J. That means that Elena reads 4/5 of the pages Jada does, or Elena reads 8/10 the pages that Jada does.